right? So there we have it, right? Somebody said though somebody had a camera that was 160 million pixels. So there you have it. So we're getting there, right? We're getting to the point where camera could be what the human experience is. Yeah.
If you have a camera that's higher than 121 megapixels, will it just look the same?
I know, yeah, I know. Is there an ability to see the difference, right? And certainly if you've got, what is the rule? You got to have twice. If you have twice that many pixels, I'm pretty sure the answer is no. You could not possibly tell the difference, right? And I don't know if it's the same rule for hearing, right? If you sample it twice what we can hear, so if you sample it twice 20,000 hertz, right? Then you know, I don't know if it's the same rule, but I'm just going to throw that out there. So here's, you know, this is the final and most complex question, but it's not really that hard. We might have time for robots after this.
Yeah. Oh, baby monkey.
Okay, so Nikon D3X CMOS sensor has a sensor size that's 3.5 times 24.0 mil. I just got this off their website, right? So the first question says, what's the area of each pixel? Okay, so let's just be careful, right? The area is going to be, I believe it's going to be the area of the sensor divided by the number of pixels, right? So that's going to be 35.9 times 10 to the minus third meters. And I do it this way. I don't try to convert square millimeters to square meters because most people don't know that there's a million square millimeters to a square meter, right? Okay, so it's 24.0 times 10 to the minus third. And this is meters, right? And then I'm going to divide that by the number of pixels, so that's divided by 6,048 by 4,032. That's got to be in parentheses, because if you don't do that, why? 35.9 e minus 3 times 24 e minus 2. That's a 4, not a 9. Right? Divided by parentheses 6,048. That's a lot of pixels.
Where did the negative 3 come
I'm turning millimeters into scientific notation.
from? No, I mean the other one, in the 24.
Same thing, they're millimeters. Yeah, aren't they? Up there? So mil is times 10 to the minus 3.
Yeah, no, I know that, but where do you live?
60.
Sensor size is 35.9 times. The sensor size is 35.9
Sensor size,
times
okay.
24.
Okay, let's see what this says. This says that we have a scant 3.533 times 10 to the minus 11 square meters per pixel, yeah? Anybody else get that?
No.
You forgot one of these minus 3s, I'll bet. Right? If light with a photon flux, here's the million-dollar question, of 4.5 times 10 to the 19 photons per square meter per second. My God, how are we going to do this, right? Okay, so let's just, we want to know, we're going to take 4.5 times 10 to the 19th, and this is photons per square meter per second, right? Okay. That's per square meter per second is incident on the sensor for 1/250th of a second. So that's our shutter speed, right? Okay. So we're going to go 1/250th of a second, right? And that'll cancel out seconds. What is the resulting charge of the pixel? Good golly. Don't we have to multiply by square meters to get photons? I think so, right? I'm going to go 3.533. Yeah. So now we've got photons, don't we? Yeah. So how do we turn photons into charge? At this point I do have photons, right?
Yeah.
Because we got photons per square meter per second. We multiply by seconds, we multiply by square meters, right? Okay. So now to get, what do we do? Oh yeah, smarty pants. Yeah, 2 to the 11th would be kind of big. Right? Okay, so now we go, I'm just going to go 0.7 of those right, times 1.602. Where'd the 0.7 come from?
30% efficiency.
Yeah, right, 70% of them are going to put this much charge on there, right? And that's coulombs per photon, right? Right, so photons now go the way of light, and I guess we've got the charge. Is that what the question is? What's the charge? Okay, that's good. Okay, so I'm going to multiply the number I've got here by 4.5 e to the 19.
Murray knows what we're supposed to be doing.
I'm going to divide by 250. I'm going to multiply by 0.7. Multiply by 1.602 e to the minus 19. And I get, after selling my soul to the devil, I get 7.13 times 10 to the minus 13th coulombs. So if the voltage is 2.4 millivolts, what's the capacitance of the pixel? Well, I think I have a formula that can do that, right? Capacitance is charge over voltage, right?
Yeah. Is that capacitance?
Right, so I'm going to take that charge, that's 7.13 times 10 to the minus 13th coulombs, divide by my 2.4 millivolts, 2.4. So divide by 2.4 e to the minus 3. And I get that the capacitance is an unlikely 2.97 times 10 to the minus 10 farads. Right? And I highly doubt that because that's 297 picofarads. Seems like a big, but it might be. On an unrelated note, for D, if I'm 183 centimeters tall, but my image on the sensor is 19.2 millimeters.
Proportional.
Right. What's the magnification? Is it really magnifying me or is it smallifying me?
Smallifying.
Yeah, so it's going to be like a really small number, isn't it? So how do we make those two? It's a simple ratio. How do we make it a small number? Do we divide the 19.2 millimeters by 183 centimeters?
Yeah.
I'm thinking that, right? So the magnification is equal to 19.2 millimeters. So that's
We don't have to
minus
convert them to the same unit.
Yeah. Divided by 1.83 meters.
Good.
So totally unrelated to everything we've done
Now I
before.
hear better.
Here's this random idea of magnification, right? 19.2 e to the minus 3.
What was the negative 6?
That's micro. Yeah. I think after that you need the binary solo.
Binary solo, let's go.
I think we need baby monkey.
Baby monkey.
Baby monkey.
Mary's exact same
What's up at the top?
Baby monkey.
This is still pretty good. No. Go to the very beginning.
Tomorrow is no hours. Our programming determined that the most efficient answer was to shut their motherboard fucking systems down.
Now he does talk to the humans, they a little understanding, but make things better. Can we talk to the humans and work together now?
No, because they are dead. I said the humans are dead.
He's right, they are dead.
The humans are dead.
Sniff this one instead.
With traces of lead and the poison their asses.
Actually, their lungs.
Binary solo.
0 0 0 0 0 0 1 0 0 0 0 0 0 1 0 0 0 0 0 1 0 0 0 0
Come on, sucker, lick my back.
The humans are dead.
Once again, without emotion, the humans are dead, 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 dead.